Okay, so welcome back once again. All right, so we are on 8.5. That is last sample test for population proportion. So now we are off from the mean. We are going to the proportion. It's just the same approach like last sample test for population mean. Okay, but now we are using the p. So we go through the same process that we did for the mean, just that here we are using what the proportion, and there's a calculator way of what doing this as well. All right, so as you go through, you're going to use what the calculator way. So always your mu naught or your p naught is what you hypothesize. So what you hypothesize, you write it under h naught and what ha. So use their symbols, the mathematical symbols appropriate for each of what these two contradictory statements. And your p hat is what you actually calculate from your sample. Okay, just as the S bar we calculated from the sample. So the same approach applies. So since you are using last sample, you always use what? The Z or the standard normal hat distribution. And for you to determine that indeed you have last sample, NP and NQ, all of them should be greater than what? 5, greater or equal to 5. All right. So this is if you determine the direction based on HA. Okay. If you are going to the left, you use all of our alpha. If you are going to the right, you use all of our alpha. But if you are going for left or right, then we divide our alpha by 2, okay, to determine our rejection region. And we've talked about this before. So here, you have to perform the indicated test of hypothesis using the p-value approach. So it implies that we need to get what? We need to get a probability value. Then we compare it with what? Our alpha. Then we make what? A conclusion. So under HA, we have 2 directions. So how do we get our p-value? So for the p-value, we can get it through one proportion z-hat test. Okay, but if you hit on the one proportion p-test, it asks you some questions for which you need to fill. So if you hit on the stats and you go to tests, so all the tests that you're going to do, so under all the tests that you're going to make, all the tests are here. So one proportion z test, that is 5. Hit on it, it asks you p naught. So the p naught is what you actually hypothesize, okay? And the s is the number of what you're interested from the sample out of your n. So if you have s over n, that gives you what? Your p hat. So in this question, we have our p naught to be 0.15. Okay, so you have our p naught to be 0.15. Then now we go to the sample. How many s do we need from the sample divided by our n? So the n is given to be 1,600 from the question. So we come to 1,600. So it's left with 1. Our S, we don't know. How do we get our S? From the formula for P hat. P hat is giving us S over N. But here, P hat has been giving us what? 0.18. So by substitution, then we multiply our 1,600 by what? P hat, then we get our S. So what you do is that if you want to get your S, always is P hat times what? Times N. Okay, this gives you back what? Your S. Then you are good to go. So we did that and we had the S to be what? 288. 288. So 288. We are good to go. Now, which direction are we going? We ask ourselves, we are using what there, not equal to. So that's what we are using. Then we calculate and that will give us our P. So we have our Z value, we have our P value. So now our P value is what? 7 points. Almost 8, approximately 8. So 8 point something. So in case you want to also draw it. Oh, now let's go back. So stats and proportion. Okay, so in case you want to draw it too, it gives you the p-value there as well. So it's 8, approximately 8 times 10. So if you see e to the power negative value, this is the same as 10 to the power minus what? 4. And since you have 8 of that, and it is 8 times that. Okay, so always if you see a value like this for the P, you can convert it back to this. But how do we convert this back to decimal places? Now we want to cancel all the -4, the 4 that we see. So we start from the 8 and we roll back 4 times. So we start from here, 1, 2, 3, 4. So we bring the point back here. So the point was here, we brought it back here. So the empty spaces, we put 0 there. So this is 0, 0, 0. Okay, so now it will be 0.0008. So this, the whole of this has been converted back to this. So this would be your P value. Okay, this will be your p-value that we have. So when you see something like this, then you compare your p-value to your alpha. Okay, since we are using two direction, this has calculated the two direction for us. We don't need to do anything. Compare this to your alpha, and the alpha is what? 0.001. So you compare it to that and you're good to go. You make a decision out of that. Okay, we do same for this. So we get our S. So like I said, S is P hat times N. Then we are good to go. We are using just one direction. So you choose from that direction that we want to use. Then we are going to get what? Our P. So this is the P value, one direction. We get the P value. We are good to go. Okay, so now this is the p-value approach. You can also do that of the critical value approach. Okay, this is the p-value approach. You can do same for the critical value approach. So for here we have a word problem for which we need to get our information from. So always note that your p hat will be something you calculate from the sample, but your p naught or your p is something that we hypothesize. So we hypothesize either before we get our sample or within the question. If you want to solve some particular question, we do the hypothesis there. So always know that your P naught might be different from what your P hat, or it could be 0 as well. All right, so we do that. From this question, we have our P value. When we hypothesize, we add it to 0.5. Okay. So we took a random sample of 600 likely voters among them. So 370 preferred candidate 1 and 200 preferred candidate 2, and 30 had yet to decide. Determine whether there is sufficient evidence. So we have to test at a 5% level of success. So this is our alpha, okay, to support the CNN political analysis claim against the default that the population is evenly split. So this is what we hypothesize. The population is evenly split. So it implies that our P is what? 0.5. Okay. So if they are evenly split, it implies that they are equal. So either P is equal to 0.50, or the analysis claim P is greater than what? 0.50. Okay, so we hypothesize this, then now we get our data. So our P hat from the data, we have the S to be what? 370, and out of this sample, our N is what? 600. So we do this minus that, then you're good to go. But in case we don't want to go through this approach, then you can use our calculator to also get our Z value. Okay, so all you need is to get your S. Your S is what? 370, and your N is what? 600. You choose the direction that we are going. We are going to the right direction. Then we draw. If we draw, we are going to get our Z value and our P value. Okay, so we have the P value to be 0. That's what you see here. And our Z value. So either you can calculate your critical region and to make your conclusion with respect to that. The same analogy applies here. So we go through the same process. Okay, so because of time, I'm not going through all the examples, but in case you have any question, please do or to email me and I'll be glad to take you through one after the other. Okay, so this is the same approach as we did for the population mean, last sample for population mean, but here we are using what? The proportion, and I've shown you the calculator way. So with the population proportion, we need S, we need N, and we need the hypothesized value. Note, the hypothesized value is different from the P hats. The hypothesized value, we don't need a sample to get it. It's something we assume to be there. Then now we get a sample to test it. So out of the sample, we get our p-hat or what, our s-bar. Then we are good to go using the calculator. Okay, so we have examples here, as you can see. Okay. In case you have question, please do what to ask me. So this question is not a proportion question. Based on the sample, we are using average. So we go back to what? Our average. But we check whether the sample is large. We have n to be 5 and the sigma is not given. So here we use what? Our t. Okay, so this is an example that we just did. Then we calculate our t test statistics. And either we use the p-value approach to make conclusion. So if you're using p-value approach, you use this, compare it with your alpha, you're good to go. Or you calculate your inverse t to get your critical region, then you're good to go. That is that for section 5, so last sample. Okay, but this question note, since you are using average, we are using what? The mu. Okay. All right, thank you all. And if you have question, please, I entreat you to email me and I'll be glad to go through once again. Thank you.